This presentation covers the Renaissance Energy Solution example of a capacitive touch slider and button functionality on the Renaissance Energy S124 Developer Kit. This video is related to the Capacitive Touch Sensing Unit CTSU slider example on DK S124 application note that introduces the basic usage model of the capacitive touch slider and button functionality on a Renaissance Energy MCU. This video shows you how to bring up the CTSU slider function using the CTSU framework on Renaissance software platform SSP version 1.2.0. You should be familiar with the E2 Studio ISDE configuration tool for Synergy MCUs. You should also be familiar with SSP concepts like frameworks, callback functions, and SSP APIs. Although the video is much shorter, it should take about 2 hours to go through the application note and bring up a sample project. The following topics are covered in this application video. An overview of the Capacitive Touch Sensing Unit. Identify the hardware used in the application note. Step through the CTSU application configuration data. Review the SSP Capacitive Touch framework, including creating the CTSU thread, creating the CTSU framework, creating the CTSU button framework, copying over the Capacitive Touch CTSU configuration files, and verify the CTSU application project. This video is based on the application note Renaissance Energy Project CTSU slider example on DK S124 as of August 3, 2016. This application note is available on both the Renaissance Energy website, renaissance.com, under Products, Renaissance Energy, Resource Library, Sample Programs. It is also available under the Renaissance Energy Gallery website, listed under Support, Resource Library, Sample Programs. The sample application targets Renaissance Energy S124 devices. To build and run the application, you will need a Renaissance Energy DK S124 board. The Capacitive Touch Sensing Unit, CTSU, measures the electrostatic capacitance of a touch sensor. Changes in electrostatic capacitance are determined by software that enables the CTSU to detect whether a finger is in contact with a touch sensor. Electrostatic capacitance is detected by the self-capacitance and mutual capacitance methods. This application note uses the self-capacitance single scan mode for the slider and button functionality. The slider functionality commonly involves detecting the sliding motion and responding to the motion. In this example, the DK S124 detects a user sliding a finger on the slider and responds by lighting up 3 LEDs. When the user slides a finger from the tip of the slider to the end of the slider, the 3 onboard LEDs will light up from dim to bright. The button functionality involves detection of button press detection and response. The example project detects a press on button 1 and responds by toggling LED 2, which is orange. It also detects a press on button 2 and responds by toggling LED 3, which is green. To build and run the application, you will need a PC running Microsoft Windows 7 or Microsoft Windows 10 with the following Renaissance software installed: Synergy E2 Studio 5.0 or later, and Synergy Software Package SSP version 1.1.0. This application note provides step-by-step instructions to use the SSP slider button framework feature to recreate this application. After opening E2 Studio and verifying the workspace location, Step 1. Establishing a new project with no RTOS included. Create a new Synergy project. Enter the project name and set up the Synergy license file. Choose the board S124DK and verify the package part number. Step 2. Create the CTSU thread. Choose ThreadX from the BSP property RTOS being used. Under the Thread tab, click the plus sign to create a new thread. Set the symbol property of the new thread to CTSU_thread. And set the name property of the new thread to CTSU thread. Step 3. Create the CTSU slider framework. Click the newly created thread CTSU thread in the CTSU thread stacks window. Click on the plus sign to add the framework. Select Input and choose Cap Touch Slider Wheel Framework on SF Touch CTSU Slider. Click the blue box G SF Touch CTSU 0 Cap Touch Framework on SF Touch CTSU and configure the Update Hertz to 20. Click on the box with the red text G CTSU 0 CTSU Driver on the R CTSU and configure the properties with the max active channels as 7, interrupt property for CTSU write, CTSU read, and CTSU end should be set to priority 1. Change the name of the module to G CTSU and change the CTSU configuration to G_CTSU_config_self. Step 4. Create the CTSU button framework. In the CTSU Thread Stacks window, click the plus sign and add the framework Input Cap Touch Button Framework on SF Touch CTSU Slider and change the number of buttons to 2. Click on the pink box and choose Use GSF Touch CTSU 0 Cap Touch Framework on SF Touch CTSU. Step 5. Copy over the Cap Touch Configs folder from the imported functioning sample project under CTSU Slider Button Config Source Cap Touch Configs to your newly created project. Step 6. Create the callback function. In this step, you should copy over CTSU thread entry.c under the sample project CTSU Slider Button Config source to your newly created project. Step 7. Click Generate Project Content from the Synergy Configurator to generate the project files. Click the Build button to compile the project. It should compile without any errors. Download and run the project by clicking on the Debug button configuration. You may want to ensure the proper ELF or ELF file is known. You should now verify the sample application by sliding your finger from the sharp end to the thick end to see the 3 LEDs light up from dim to bright. Also with this sample application, LED 2, which is orange, will toggle when you press button 1, and LED 3, which is green, will toggle when you press button 2. For more information about the Cap Touch feature, handling the slider and button callback, and detection of user sliding motion, reference the app note titled CTSU Slider Example on S124. With support from the SSP CTSU framework and the E² Studio configurator, building a slider application on the Renaissance Development Kit is very easy. The SSP package has the built-in CTSU data processing functionality and callback scheme to enable rapid slider and button application development. You'll recall from the high-level objectives at the start of this video, we were to receive an overview of the CTSU, identify the hardware used in this application note, step through the CTSU application configuration data, review the SSP CapTouch framework, including creating a CTSU thread, creating a CTSU slider framework, creating the CTSU button framework, copying over the CapTouch configuration files. And lastly, we verified the CTSU application project. This concludes this video. Thank you for watching.